Thank you very much. So I'm going to talk about some work that we've just completed looking at Camden's CO2 emissions and where we might get to in 2030 with a range of different measures that reduce carbon emissions. So I'm going to talk about that work. I've worked in this field for 25 years now, and I can tell you if it was all easy, we'd have solved it by now. And sadly, you might think we've kind of left it to the last minute because now it's an emergency, but you know, it's not been easy getting here. So what might we be achieved by 2030? I'm going to talk about. So these are Camden's emission sources viewed from a territorial point of view, i.e. drawing a ring around the borough boundary and saying what emissions occur within that boundary. So we're not including things like imported goods and the emissions embodied in that. We're not including aviation. And you might think, well, why? Why aren't we doing that? And that's partly because the government publish figures for Camden in this particular format, but also partly because Camden has less influence over those things. It's much more difficult for Camden to influence how its residents go on holiday, for instance. Do they take the plane? Do they, how do they go on holiday? So that's partly the reason. Whereas Camden does have powers over, has planning powers, it has powers over transport. There's a lot it could do to influence these sectors, though arguably it doesn't have enough powers to do everything we'd like it to do. And I'll return to that. So a quick show of hands. And those of you who've been reading those boards over there might know the answer, but which of these sectors, homes, road transport, public, commercial and industrial buildings, do you think are the majority of emissions in Camden from? So hands up for homes. A few. Road transport. A few more. And finally, public, commercial and industrial. I think the majority has got it right. Well done, you have been looking at the boards. So these are the figures. Transport accounts for just 13% of Camden's carbon emissions, so road transport. Homes are about a quarter, and the majority is public, commercial and industrial. So 80% of emissions arise from energy use in buildings in Camden. Now, you might also notice that this is 2016. Why are we not using more up-to-date figures? And the answer is we don't have them. There's a lag between getting these figures from the government so that's why we've only got 2016 at the moment. So, I was having an interesting discussion just before I started about this. So one thing we can do is we can reduce energy demand, or we can increase renewable energy supply. But we can't just do one or the other. We need both. Because if we want to get to zero carbon, we're never going to reduce demand completely to zero. There'll always be a demand. You know, if you think of an MRI scanner in a hospital, that just doesn't run on its own. It will always, however efficient you make it, it will require electricity. So we do need renewable energy as part of the picture. We can't just do it all by cutting back or reducing emissions. It doesn't always involve cutting back. So what about the road transport sector? It was only 13%, but it's still important. If we're going to get to zero carbon, we still need to address it. So the obvious answer is modal shift. So we can move from our petrol and diesel cars to cycling and walking, and obviously the energy saving there is 100%, fantastic. We can move to buses, and actually this is an electric bus, so we can move our current diesel buses to run on electricity, and that's happening slowly. And we can also move the cars that we still need to electric, and here you can see a car plugged in, an electric car plugged in via by a lamppost, so that's a possible solution for street parking. And the saving from switching from a petrol or diesel car to an electric car in energy terms is 75%. So electric motors are much more efficient
than their diesel or petrol equivalent. So big savings. Of course, they do cost more to buy, and that's primarily because of the cost of the batteries, but they are much cheaper to run. So the biggest problem area, what do we do about the buildings in Camden? And here you can see a range of building types. In the bottom here, you can see the St Pancras Hotel. Here you can see a terrace in Mornington Square. So insulating these buildings is a real challenge. And actually, whether they even have lofts that you could fill, they don't have cavity walls that you can fill. We've used up a lot of the cheap, low-hanging fruit, and we're left in Camden with primarily the most expensive measure, which is addressing the walls. And you can see in these building types that the main area of heat loss is the walls. If you live in a mid-floor flat, you've got no heat loss roof area. So tackling these is not easy, and I would wonder whether we will ever reduce the energy demand of these two on the right. Will we ever put external wall insulation on these buildings when they're, kind of heritage buildings? There's planning. A lot of the buildings in Camden are in conservation areas, have restrictions that make insulation now quite hard to do, possibly impossible. But there are still, like the two on the left in the previous slides, there are still buildings that certainly we could insulate them. And what we did in the modeling was we looked at a package of insulation measures, loft insulation, cavity wall, windows, and solid walls where they occurred, and we did a sort of weighted calculation. So the sort of weighted saving of applying all of these was 57% of the space heating demand. Obviously, you could go further. You could have thicker wall insulation and so on and get higher savings. Of course, that's possible. So I think this is probably the biggest challenge in Camden. As I think Keir Starmer said, we need to get most homes in Camden are heated by gas, by either a gas boiler inside the dwelling or perhaps a communal gas boiler in the basement of a block of flats. And we need to take them out. And that is a major challenge. And one possible solution, probably the most obvious solution, is an electric heat pump. And here we have an example of an air source heat pump. So it's essentially like a fridge in reverse. So we're taking heat from the outdoor air. And you can see there's a fan in here that runs and extracts heat from the outdoor air, uses a compressor. If you look at the back of your fridge, a little black box at the bottom, metal box, and inside that is a compressor. So it's a similar process, but it's a lot more expensive than a fridge. So we're talking, depending on the size, in the order of, at the moment, £7,500. Whereas if you had your boiler replaced with another gas boiler, it would probably cost you something like £2,000. So there's a huge additional capital cost. And the other part of the problem is there is very little in the way of a running cost saving from fitting an air source heat pump. Because although we save energy, we're switching from gas to electricity, and electricity is a lot more expensive than gas. And in the UK, we have the most extreme difference in gas and electricity prices of virtually any industrialized country. So it makes this more challenging. At the moment, there is a government subsidy that helps to combat this problem, but it's not an overwhelmingly attractive option to most people, and it's not really being taken up on a big scale. So obviously in larger commercial buildings, hospitals, schools, the biggest sectors of that non-domestic sector are actually offices and things like hospitals and universities. So in that case, you can just have larger heat pumps, larger boilers, replace them with larger heat pumps. And here's an example of a massive air source heat pump, 4.6 megawatts. So that's the kind of scale of extraction from the air that you would need to replace larger boilers. But you could use other sources. So you could use waste heat from the tube ventilation system. You could use rivers. You could use boreholes. There are lots of clever ways we could do this with larger systems. We're more limited where we're just trying to replace a gas boiler in an individual home. Lighting is happily a very cost-effective change to make, and it's happening anyway. So people are replacing halogen lamps with LEDs. They're replacing fluorescent lamps with LED lamps, and there are huge savings from doing these, and generally it is cost-effective. So that is one area that we modeled where happily everything works in our favor. Here's a more radical solution. Demolition. So we could demolish and start again. Obviously, that's not really practical, but it is happening on a very small scale. So every year, on average, Camden demolishes, or 230-odd homes in Camden are demolished and replaced with much more efficient homes. But there's 1,320 of those much more efficient homes. So we can end up counteracting the efficiency gains that we get from this process. And a similar process in the non-domestic sector, though not quite as extreme. So what do all of these have in common? What's that? Electricity, exactly. We are switching from petrol or diesel or gas to electricity. So, some of you may be old enough to remember this. It would be nice if this was an electric motor they were swapping into this car here. So yes, there are other potential solutions to this. There's only one really major alternative, and that is to move to hydrogen. So people have said, well, we could use the existing gas network, we could keep it, we could replace our boilers with hydrogen boilers, and we could create hydrogen and put it into the gas network. The problem with that is you have to create the hydrogen, and the most sustainable option is to use electricity, use renewable electricity to create the hydrogen, and there's a lot of inefficiency in that process. So you're losing 40% when you do that, and then you put it into the gas network, you put it into a new hydrogen boiler, which is 90% efficient compared to our heat pump, where we just use the electricity without converting it at an efficiency of 300%. So I would argue that probably doesn't make sense, and there's no current plans for Camden to have hydrogen in its gas network. Whereas there are plans to decarbonize electricity, and you can see just how far we've come from 2008 to now, and you can see the green is renewables, the orange is nuclear, the blue is gas, and the black is coal. So we've moved from a situation where most of our electricity was generated from gas and coal, and if we went back further, most of it was generated from coal, and we're moving to a situation where now most of our electricity is generated from renewables and nuclear, and whether you like nuclear or not, it is zero carbon. So by 2035, you can see the majority, a massive percentage of our electricity will be generated by those two. But we won't be zero carbon. So that is a challenge for Camden, because even if we switch everything over to electricity, there will still be some gas in the mix. The other thing you'll notice about this graph, perhaps, is the size of these bars represents the amount of electricity that is consumed in the UK. So you can see it's been going down and down, fantastic, all the LEDs, all the efficiency gains that we've been getting. And it's going to start going up again, the government are projecting, because, of course, we're going to be switching to heat pumps and electric vehicles. So that's going to push demand up again. And they're imagining quite a slow transition to 2050. And we'd like to do it faster, I think. Everyone would agree, I hope. So could Camden do away with that and generate all of its own electricity? The main option is solar PV, and there isn't enough roof area to do that with the current efficiency of solar PV. So we are tied to, we're not an island in Camden. We do need to be connected to the grid, and we will be importing electricity from the grid. So very briefly, what do we model in this study? We modeled all heat pumps in new build from 2022. So all new buildings there'd be no gas boilers, it would just be heat pumps. In existing homes, there would be a program of retrofitting heat pumps, and by 2030, 4,800, which sounds quite a small number, but seemed realistic in terms of budget and powers and so on. An insulation package for 10,000 homes. Taking current trends for these efficiency measures, appliances, motor efficiency, and these rates of reduction in vehicle kilometers from modal shift to 15%, 40% of electric cars and buses, 40% of overall vehicle kilometers would be from electric vehicles, and grid decarbonisation. So what were the results? So by 2030, we could get to a 57% reduction on 2005 emissions. And you can see the progress to date that we've already had. We also did a scenario where what happens if the grid doesn't decarbonise any further? What happens if all the plans of the nuclear power stations get shut down, progress stalls? And in that case, we only get to 45%. But then we also looked at a more radical solution, which I think is the kind of thing that needs to happen. We need to ban gas boilers and the retrofitting of gas boilers and offer solutions, alternatives which are cost-effective to people and don't put them into fuel poverty. And if we did that from 2022, we would get to 68% reduction. But we wouldn't get all the way to zero because we wouldn't have fitted, because the lifetime of a gas boiler is 15 years, and so we wouldn't have retrofitted all the boilers and so on. So the cost of doing our conservative scenario, an extra 380 million. For our radical heat pump scenario, the extra cost is 900 million over that period. And that's just the capital cost. Obviously, there are impacts in terms of running costs. So challenges I've really already talked about in terms of getting to net zero. Camden has powers to limit traffic and the type of vehicles, but it has no powers to stop people retrofitting gas boilers. That's something that we would need. Costs are a major factor, so heat pumps being more expensive. The grid won't decarbonise all the way to zero by 2030, and limitations in land area. So planting trees we don't have enough land area to do that, and make the net zero reality. So obviously there are other emission sources that exist. Aviation is a very hard one to deal with, and there aren't currently technical solutions for that. And the nice thing about Camden is there are technical solutions for all of these emissions. We already have them. We already have the technology to get to zero carbon. It's all about the cost, Camden's powers, and the fact that the grid is decarbonising perhaps more slowly than we'd like. That's it. Thank you very much.